Good morning, welcome to Learning Hard Academy. Today we're continuing our trigonometry lesson 34. We're in part 2 of our inverse trigonometry functions lesson today. So from the previous lesson we introduced to everyone the inverse trig functions. What are inverse functions? What is the inverse sine cosine functions? Today we're going to continue our discussion to talk about inverse tangent functions. Alright, so let's go ahead and start by looking at tangent functions. If we have tangent functions, let's just go ahead and briefly look at the domain and the range. So for tangent functions, the x-coordinates, let's take a look at the graph of tangent function. Okay, so this is the graph of tangent function. I already pulled it up. Now if you go ahead and look at the tangent functions, so x, you can plug in any real numbers for x except the multiples of negative pi over 2 and pi over 2 every pi. So starting from pi over 2 plus minus m pi, you cannot plug in those numbers because there's asymptote, because on those during those numbers cosine equal to 0. So x equal to pi over 2, or x equal to negative pi over 2, cosine equal to 0. So we cannot invert. We cannot inverse. Okay, have this inverse and still be a function if I go ahead and continue to do everything. So what we can do is we can limit. Okay, it seems to be very quite straightforward that if we limit the domain from negative pi over 2 to pi over 2, then we will have a very nice continuous curve here that we can do an inverse, because this from negative pi over 2 to pi over 2, this piece of tangent will pass the vertical line test and will pass the horizontal line test. Now remember, the vertical line test determine whether a function is a function or not. The horizontal line test will determine whether a function is a one-to-one function or not. So if you draw a horizontal line from negative pi over 2 to pi over 2, if you draw any horizontal line, it will only pass through this piece of curve once. So that is the piece that we will go ahead and do the inverse with. Okay, so let's go ahead. Actually, let me rewrite this. Okay, so y is equal to arctan when x is equal to tangent of y. Alright, so when would this be true? When would this be true? When if x is restricted, so the restriction for x, the input, is from negative pi, actually, alright, hold on, let me go ahead and grab this. Alright, so now y, the input value for the tangent is restricted from negative pi over 2 to pi over 2, so that is going to be the output value of between arctan. Okay, so let's go ahead and grab arctan and let's go ahead and see what happens. If you grab arctan, okay, let's see if I can turn this on. Okay, right here. Alright, so you can see this green curve is the reflection of this relative piece of curve across the line y equal to x across the diagonal. So as you can see, this arctan, you can input any value from negative infinity all the way to positive infinity, but as you approach negative infinity, you will approach negative pi over 2. As you approach positive infinity, you will approach positive pi over 2, because the limit negative pi over 2 and pi over 2 will be the limit there. Our output value will never be equal to negative pi over 2 or pi over 2, because tangent is not defined there. So x can be limited, the input of arctangent can be limited between negative infinity and positive infinity, and the output will be limited between negative pi over 2 less than y less than pi over 2. Now notice that they are not equal to. X cannot be equal to negative infinity or positive infinity, and then y cannot be equal to pi over 2 or negative pi over 2. So just between those numbers. So this is the basic understanding for what a arctangent is. Okay, so how do we work with this arctangent? All right, let's go ahead and take a look at some examples. For example, now and arctangent also follows the pattern of arcsine. All right, in terms of the primary values it returns. So let's go ahead and draw a little. I'm sorry, let me go ahead and draw it right here. Let me draw a little quadrant to indicate, because if you look at the graph, okay, we can see that arctangent, okay, covers, okay, tangents. When we limited restriction when we restrict the domain for tangent to come up with the arctangent function, we restrict it from negative pi over 2 to 0 and 0 to pi over 2. So that means negative pi over 2 is here, right? And 0 is here, and pi over 2 is here. That means arctangent will operate in the 4th quadrant and in the 1st quadrant, just like arcsine, okay? So let's go ahead and summarize what we talked about yesterday. And this is pi, and this is Q2. So remember from previous lessons, arcsine, if we have input approximate number, a positive input for arcsine, it will return the angle in between 0 and pi over 2, between 0 and 90 degrees. If we input arcsine a negative input, it will return the negative angle from 0 to negative pi over 2. And so does arctan. So arctan follows arcsine, alright? Now, in fact, if I have all arc functions, if I input a positive, it will always return to me the angle between 0 and 90 degrees. That's the primary. So later on, we're going to do arcsecant, arccosecant, arccotangent. They all will be in quadrant 1 if you input a positive angle. I mean, excuse me, input a positive measurement, and then it will return a positive angle from 0 to 90 degrees. But arccosine works in quadrant 2. When you input a negative angle, it will return an angle between pi over 2 and pi. That's 90 degrees and 180 degrees. So let's go ahead and take a look at this now. So let's say tangent pi over 4, tangent of pi over 4 is equal to square root 2. No, it's equal to 1. Okay, so that means arctan. Okay, let's do some example of 1 should give us pi over 4. Okay, now tangent of negative pi over 4 is equal to negative 1. So that means arctan of negative 1 will be equal to negative pi over 4. But this is not always so, because those two angles I give you examples out there in quadrant 1 and quadrant 4, so they return very beautifully. However, if I go ahead and do, let's say, tangent of 2 pi over 3, okay, tangent over 2 pi over 3 is negative 1 over square root 3. Or actually, no, I'm sorry, it's negative square root 3 over negative square root 3, yeah, negative square root of 3. And so arctan 2 pi over 3, no, I'm sorry, arctan of negative square root 3. Arctan of negative square root 3, however, should return to an angle that is in quadrant 4. So that will be a negative pi over 3. Negative pi over 3. Okay, so this is the relationship. Arctan will never return the angle in quadrant 2. Alright? Alright, so let's take a look at some other inverse functions. We'll do a little bit more practice later on, but we'll go ahead and look at some other inverse functions as well. So now let's take a look at the secant. Okay, so y is equal to arcsecant of x. If x is equal to secant of y, then y is equal to arcsecant of x. Okay, so they are inverse functions. Now, so let's go ahead and take a look at secant, and very quickly, let's graph secant right here. Secant of x, okay, as you can see, secant of x looks like this. So we definitely will not be able to graph whole inverse. We will not be able to inverse the whole function of secant. We still have to do a domain restriction. We have to restrict the domain of secant in order to come up with an arcsecant that will work. Okay, and so in this case, what we do is we restrict we restrict the secant from second quadrant, it's actually first quadrant and third quadrant. Okay, so there are several ways we can do this. Let's go ahead and graph our secant to show you. So as you can see, arcsecant is this piece. Now this piece is the reflection of from the first quadrant from 0 to pi over 2. That's the positive one. And then this piece is the reflection from pi to 3 pi over 2. Okay, it's kind of hard to see, but this blue piece is right here. Okay, as you can see, this point is negative 1 pi, right? So it's a reflection of that point, negative 1 pi, and then it keeps going like this. You would go to as you can see, this is the point of this reflection point. Okay, so this is the piece over there of this piece. But what we're gonna do is, in order to make the operation work, okay, let me go back to the other side. Alright, so in this case we're gonna limit x to greater than or equal to 1 and x less than or equal to -1. And what about the y? The y output will be between 0 and pi over 2. That's in this first quadrant. And okay, negative pi over 2. Actually, it should be between negative pi less than or equal to y less than or equal to negative pi over 2. So this is a little bit different than that's arcsine, arccosine, arctangent, because they're not continuous. The two intervals that you will return, the angle will be a very different situation. It will be quadrant 1 and quadrant 3 actually. So we're gonna put in the our chart a little bit later. Now, what about cosecant? So if y equal to arccosecant of x, alright, it will follow the same pattern. X greater than or equal to 1 and x less than or equal to -1, because our arcsecant and cosecant have the same domain range in this case. Now, its principal value also will return between the first quadrant if you input a positive ratio, positive segment. But if you input a negative segment, it will also return to you in quadrant 3. This is between -90 degrees and -180 degrees. Okay, so it's going to be greater than -180 to -90 degrees. And then let's look at the cotangent. Alright, now cotangent follows the tangent. Okay, so the output will be negative infinity less than or equal to x less than positive infinity, and then the y values should be between the y values. Take a look. Okay, the y values will be between 0 and pi. Okay, so our arccotangent actually follows cosine here. Alright, so what does that mean then? What does that mean? That means, let's go ahead and draw this quadrant chart again. Okay, so let me go ahead and put all the arc functions, cosine functions. So this is quadrant 1, and it's from 0 to pi over 2 to pi, right? But this is going this way. This is 0 from negative pi over 2, negative pi over 2 to negative pi. Okay, so going counterclockwise, we're going from 0 to 90 degrees to 180. Going clockwise, we're going from 0 to negative 90 degrees to negative 180. Okay, so when we input the positive value arcsine, you will return the angle between 0 and pi over 2. So we recall that quadrant 1, and then it's actually the same thing for all the arc functions, all the inverse functions. So doesn't matter what arc functions, if you're taking a positive input for the arc functions, so arcsecant, arccosecant, arccotangent, if you input all the positive, okay, into the input for any of the arc functions, you will get an angle back between 0 and 90 degrees, quadrant 1. Now, in let's see. So arcsine, when we input the negative value for arcsine, it will return a negative angle between 0 and 90 degrees, 0 and negative 90 degrees. So will arctangent. Okay, so the value returned to us will be arctangent. If I input a negative number into arctangent, the output will be a angle between 0 and negative 90 degrees. And arccosine, if you do the negative, it will return in quadrant 2. And arccotangent, it will do the same thing in quadrant 2. But arcsecant and arccosecant will return us, if we do a negative arcsecant or arccosecant, the angle will return to us is in third quadrant, but the third quadrant will be between negative 90 degrees and negative 180 degrees. Okay, so we'll do some example of that, but this is a very important chart. Now, primarily, we'll be working with arcsine, arccosine, arctangent, and then those are the three major functions we'll be working at. But arcsecant, arccosecant will be doing some examples of that as well. Now, you can always use your calculator to do it, to calculate arcsine, arccosecant, and arctangent. But however, most of calculators do not have arcsecant, arccosecant, arccotangent. Most of calculators only have arcsine, arccosine, arctangent. Okay, so but it's not a problem. We can do a lot of this by hand as well. Arcsecant, arccosecant, arccotangent are important later on in calculus, so we do need to know how to do that. But they have the same properties. It just follows a different quadrant there. So let's do some examples. See if we can get through some examples today. Alright, so let's do some basic arcsine here. Square root 2 over 2. Alright, arcsine is square root 2 over 2, which means that it will return an angle in quadrant 1 that has a sign of square root 2 over 2. Now, if you remember you're in a circle, you should know this is equal to pi over 4. So the angle is pi over 4. Alright, what about arccosine of 1/2? Okay, arccosine 1/2 will return to us an angle in first quadrant. That should give us, let's see, 1/2. So if you look at the unit circle, it will be as 60 degrees unit circle, 60 degrees angle, which is pi over 3. Okay, so arccosine 1/2 will give us pi over 3. What about arcsecant negative square root 2? Okay, well, when secant is negative square root 2, what it means is cosine is equal to negative square root 2 over 2. So it will be the 45 degree angle that has a 45 degree reference angle in quadrant 3. So that case is going to be let's see, 1 pi over 4, 2 pi, 3 pi, 4, 5. This is going to be 5 pi over 4. So this angle will be 5 pi over 4. Okay, let's try arctan of negative square root 3 over 3. Okay, now negative square root 3 over 3 is the same as negative 1 over square root 3, but we're going to get angle back in this quadrant. That means the ratio of a sine over cosine, that means the ratio of sine and cosine is going to be 1 over square root 3. So this is going to be pi over 3, negative pi over 6. Negative pi over 6. Alright, let's try another example. Let's try arccosecant of 2. Now, when we do arccosecant 2, what it means is arcsine, the sine value is 1/2, right? Because cosecant is reciprocal of sine. So this is a sine of 1/2. But so it's going to be the first quadrant, and then we're going to think of the angle that has a cosecant value of 2, which should be equal to pi over 6. Okay, pi over 6 sine value is 1/2, so the secant value is cosecant value is 2. Alright, let's try another one, last one. At least this one for the cotangent of negative 1. Okay. Alright, our cotangent negative 1. That means the cotangent value has to be negative 1 as well, because it's reciprocal of that. But our cotangent, if we input a negative, we're going to be looking for an angle in quadrant 2. So the 45 degree, the angle that has a 45 degree reference, which is 135 degrees in quadrant 2, now it has a cotangent value of negative 1. And so it will be 3 pi over 4. Okay, so doing secant and doing cotangent will be a little bit more, and arccosecant, it will be a little more different when you have, especially when you have a negative, because you have to remember which quadrant they are in. Okay, so now I think we have been talking about the all the arc functions a little bit. Now I haven't shown you the graphs. Okay, let's go ahead and go back. Okay, this is arcsecant. Let's just go ahead and take a look at what would cosecant, arccotangent looks like. Okay, very quickly. So let's do cosecant. Cosecant of x looks like this, and what would arccosecant look like? Okay, arccosecant, again, this is a piece that's separated. Now, this is a piece that's definitely broken off. So, in arccosecant, we are using quadrant 1 and quadrant 2. Quadrant 1, arccosecant, we're using quadrant 1 and quadrant 3 there. Yep, arccosecant quadrant 1, quadrant 3. Alright, and then what about arccosecant cotangent. Okay, cotangent looks like this, and so as you can see, cotangent is very nice. We're going to use this main piece as our main restriction for inverse from 0 to pi. So when we do arccotangent, oh, that's not what I wanted. Excuse me. Go to the next one, and let's do arccotangent. Alright, so it will be this reflection of this main piece from 0 to pi. Okay? Alright, so if you have any other questions or comments, please leave a question and comments in the comment section. We'll continue to talk about more inverse functions in our next few lessons. Thank you.